Alrighty, how's everybody doing? Welcome to the stream. Keeping an eye on the audio level because I totally forgot to check the microphone before we got started. So, whoops. All right. We're going to end up doing. So, we're not done with the Apple II schematic, but I need to work on something else. So we're going to be designing an RF circuit tonight. Using an nRF70202, which is a Wi-Fi chip from Nordic. I've got a project coming up where I'm going to make use of one, and so we're going to make a board for it. How many ohms are we adding today? We're adding about 50 ohms because we're going to do lots of 50 ohm stuff. Yeah. So by the way, a couple things. There is a new Workbench Wednesdays video that came out. Latest. Came out on Wednesday. I got to tour Eaton's process control showcase, which was pretty cool. Got to see like pumps and PLCs and stuff like that. So yeah, you can go check that out after the stream, of course. Yeah, and then this past weekend I was at SuperCon, Hackaday SuperCon. Talked about the Mega 2E project. And so that was really exciting. I'm looking forward to when that video comes out. And then in a couple of weeks, the final video on that project will come out as well. So lots of stuff going on. Okay, let's get to work. Yeah, so this is the reference schematic for this NRF chip. What I want to do is combine it with, I'll tell you what, because I need to pull one of these up anyway. Because I need to know which one it is, because we'll be needing to look up its pinout here in a little bit. Let's go to newark.com. I'm going to search for a XIAO. And there should be an NRF. Yep, so it is based on the 52840. Okay, so let's get this. Oh, that's nice. Okay, so what we're going to do is we're going to go to Seeed. And we're going to search Seeed Studio for that number, and that should bring us to this page. Okay. Actually, yeah, that'll be fine. And then on this page, what I'm looking for, I want to know what pins it's using because we're going to need to know that eventually. Because I need to know, what do you call it? Where the SPI port is at, because that's how you can talk to the nRF72. So I'm looking now for a schematic. And as you probably know, I'm not a super big fan of Seeed Studio anymore because I've come to realize they're really terrible with their documentation. Although their hardware tends to be pretty good still, but it's not usually documented all that well. So what is this? This might be the total data sheet. Yeah, that's not what I want. I've got that already. Here's a XIAO reference design. But yeah, that doesn't tell me anything either. What I need is, I need to know what pins on the nRF52 are connected to the pins on the XIAO. Maybe this will have it. This looks promising. I remember finding my way to this document. I guess this is their wiki site. I found my way to this a really long time ago, and it seems like they need to be a little more prominent about this wiki. It'd also be nice if they would, I don't know, occasionally update it. But, you know, whatever. Okay, so I'm going to throw that here, and then let's see what I'm looking for still. Apologize, I could have done this ahead of time, but I want to know, is it this table? No. Now the one downside is I don't think these offer the quad SPI, which is unfortunate. It means we're not going to get full speed out of our NRF chip, but that's okay. Basically what I want in a building is something that will detect when an LED turns on, which I'm actually going to use it on my dehumidifier, because when the LED turns on, it means it's full. And then I'm going to have it send a message by MQTT to let me know that it's time to empty it. But I need to know what the SPI port is on. Like, why can't they just give me a pinout? Maybe this is what I want. Yes, this is what I was looking for. Aw, they use Eagle. Shucks. Sure would be nice if people that claim to be having open source hardware would actually use open source tools. Just saying. Okie dokie. So let's go and throw this into a directory. I need to go to, where am I going? I'm going here, then here, then here, then here, then here. Okay. Wait a minute. Did I do that? Yeah, I did that right. Whew. Route the water from the dehumidifier into a humidifier. Yeah. Yeah. Yeah, it's actually kind of frustrating because I have a drain that I could connect. I could actually just have a hose, but it's in an awkward position, and so I don't think I could. It wouldn't actually be. It's not in a good setup. So, and in the summer, it drains about 3 times a day. And so what would be really nice is it's actually more for the winter time, because in the winter it takes much longer for it to fill up. And so like it could take 2-3 days before it's full. And I'd rather, I guess I could still empty it every day, but I'd still like to know. That's going to be my short-term project. Long-term, the thing I actually want to do is use machine learning to detect vibration to tell when things like the dehumidifier are actually running. And then I will keep track of how long they run, because I would like to know after, say, 1,000 hours, it's time to clean the filters. Or just get an idea of how often is it cycling. So I've got a couple of other ideas I plan to do with it. But this is just going to be like the initial step. So, okay. I did all of this. I think what I would like to do, unless there's something on here that more specifically tells me the pinout. Like, I'm curious what this is. Okay. See, look at this. I talk crap about Seeed, and here's a document. This is the exact document I think I want. If this is correct, I think this is telling me that D3 on the XIAO is 029 on the nRF chip, this is exactly what I need. Okay, this doesn't make sense because there shouldn't be a D unless I wonder, I should have done this before stream. I should go grab this board. Does this have an additional exposed pads? No, it does not. It does have a battery thing though, which I assumed it was going to have. That's weird. So the problem with checking the current at the plug is that you have to, in order to correctly measure the current, like with a Rogowski coil, or even a Hall effect sensor, is you have to separate the conductors. Because if you just put like a clamp around a cord plugged into the wall, the magnetic field is practically zero because it the two conductors cancel each other out. And so you have to separate the conductors so you can get the clamp around a single. You have to separate the cord so you can get the clamp around a single conductor, and so that makes it really difficult to do any kind of sensing. So yeah, in a case where you can do that, yeah, that's actually the easier way to do it. But that's why I want to do it by vibration, because yeah. Now, what the other thought I have is if so for the dehumidifier, the vibration's not as critical because it's going to be either like that one. I could probably just do a simple if it's greater than this amount, then it's on. But like say I want to hook it up to, I could also do this with say the washing machine. And then the washing machine, not only could I know when it's done, I could detect where in the cycle it is based on the vibration. Another thought I have is, so I have a pump system for my my heater. I could use this on the auxiliary pump, or I could use it on the main system to tell the vibration of when it is actually heating the water versus cycling the water. I could then get 3 levels. I could know how long has the pumps run and how much gas is it actually consuming, and so stuff like that. So I think there's a lot of opportunity by being able to sense the vibration, but yeah, I need to get to a point where I'm actually able to send Wi-Fi. And yes, I know there's the ESP32, but long story short, this is a video for Nordic. So okay, all that, I got completely sidetracked. Imagine that. So what I would like a better understanding. So this is D3 of the XIAO. So let's come back to here. And then I think this has like the pinout board, right? Where did I see that at? That's all good to know. Yeah, this one. So there's like D0, 1, 2, 3, 4, 5, 6, 7, 8, 9, excuse me, and 10. And then over here, I see D, I don't see a D0. Oh, huh, it's down here too. Okay, that's fine. The NEMA power meters, but don't those plug into the thing? Like, because that's, I mean, that'd be the other thing, is you could build something that plugs into the AC, but I really don't like messing with AC. Like, I would prefer not to at all. Okay, cool. I just realized also I don't really care. Okay, well, this is actually helpful because this tells me that, okay, so we're going to document this super quick in the KiCads. Why Windows Y? Why? All right, let's do a quick document. I want to do D10 is Moise. D8 is Sklock. And D9 is Miso. I feel like there's a chip select missing here. Maybe it could be anything. And then let's go ahead and, you know what? Let's go ahead and do it this, because we're already there. So D7 is going to be Sir1 RX. And D6 is going to be Sir1 TX, but I think we don't need that. D13 is an LED. That's good to know. D1 and 2 are empty. D2 empty. D1 empty. Actually, these are analog even, so that could be useful. All right, so D11 is another LED apparently. LED, oh, that's red, green, okay. And then D4 is going to be our SDA. And D5 is SDS clock for I2Cs. And then I don't care about NFC. I wonder if D31 is the battery. Okay, that only matters in code. Okay, yeah. So that's interesting. See, that's the interesting thing, is they're defining the quad SPI pins, but I don't think we have access to those. I wish we did. I want quad SPI. P019. Yeah, okay. That's fine. Whatever. Plug-in meters with an API would be useful. Yeah, there's actually LN14 just did a road test on something from Schuster. I can't remember the name of the company. It's not one that I recognize. It might be owned by somebody else. And it's basically it's a relay and it's a power meter. So you plug it in and then it does like a MQTT of the stats, which I think is really useful. But it's all proprietary. Like you have to use their app and their cloud, and that bothers me. Like I actually have a couple of kilowatts, and I wonder maybe it'd be worth hacking those so that they could do MQTT of their values, because there are a few things I could plug them. Like I would like to have it. Like I would like to know things like how much energy does the clothes washer actually use. Like I think that would be interesting information. Okay, so that's our pinout. That's going to be super useful. Now, next up, I need to find, I believe I have, yes, I do. Okay, so let's add a XIAO. Oh my gosh, waiting for footprints. This is like the worst thing. One that uses Zigbee? Yeah. I don't, does a lot of stuff use Zigbee? Because like for my home assistant stuff, I was just planning to like fire up. Not even fire up. I have Mosquito running on one of my Raspberry Pis, and I just dump stuff to that whenever I want to capture something. All right, so Seeed Studio XIAO. Okay, so let's start here, and then I'm gonna bring my text over here, and what do we got? All right, first thing we're going to do is we're going to edit this symbol, the local copy inside of this schematic only, and we're going to turn this into a yellow because that looks much better. Now, ERC is going to complain that we messed with it. I don't care. I'd rather have this. So D0, which I never did find, I don't think I actually found. Oh, D0 is blank. D3 is blank. Okay, that's actually good to know. That looks good. Actually, I should probably move all those over one more, but I'm not going to. And then D0 is empty. Okay. Okay. So D0, 1, 2, and 3. And then 4 is SDA. 5 is Sickle. 6 is TX. 7 is RX. 8 is S-Clock. MISO, MOISO, 3.3, ground, and 5. Sweet. Interesting. I've always thought about building like a universal gateway, and in fact, with something like an nRF52 and now this 7002, and then say like a Zigbee radio. And the reason I'm picking nRF is just because they have really good support for practically all the protocols. But I think you could pretty easily build a gateway that converts everything into something else. I actually thought about doing that as a project, but I don't know stuff. I don't know all of that well enough yet to be confident in being able to. Oh, jeez. Just got a neighborhood alert. Did anyone else's house just shake? I think it was a helicopter or an airplane. If a helicopter can shake your house, that's scary. Like a low-flying 777 could easily cause a little bit of a rattle. I just can't imagine a police helicopter or a news helicopter getting close enough to your house to actually shake your house. That seems a little... Also, when you hear it, like, what? Okay, whatever. Okay, first up, we're going to do MOIS. I'm going to do one of these, and then let's do, actually, I changed my mind. So let's do this. right, and then I'll insert this one. We're going to move this over here because I have a feeling we'll end up using the pins. I just don't know how we're going to use them yet. Yeah. Well, so, I mean, I do live in Chicago, and yeah, lots of the jokes people make about Chicago are somewhat true. And so one thing that does happen is I do, and I'm not too far from the highway. So whenever there's a high-speed chase, I can usually hear one of the helicopters. Not so much inside my house, but if I'm outside, I can definitely hear it. And so that's why I'm also sort of laughing, because it's like if a helicopter was close enough to your house to shake it, I just don't get it. Anyway. Yeah, I don't think somebody posting on a Facebook-like app about whether or not a helicopter is shaking their house knows how to use ADS. I do. I have it set up on my Portapack, and I've got a cute antenna from the Aerospace Village that is in the shape of an airplane. It works really, really well. I can go outside, and I can. When my mother was visiting, and we went outside, and she was watching on the Portapack, and she would give me the tail numbers, and then I looked up on FlightAware where the flights were coming from, and in the dusk, we could see the planes well enough that I could at least identify usually the airline, and roughly I can tell the difference between, say, like a 737 and a jumbo jet, but I can't like necessarily tell the difference between a 747 and a 777 from where I'm at. So anyway, it was really fun because it was like, I don't know, it was just kind of cool. So whatever. Anywho, that was a story nobody asked about. Okay, moving on. I'm going to let's just go ahead and make number 8 be the chip select, because I'm pretty sure we're going to need a chip select. And then the other side, I'm just going to leave it open for the moment. Same thing with the power. Because what bothers me is I did not realize this was not going to have power. And I kind of don't want to deal with it. And then this doesn't have the pads for the battery. What to do about battery? I don't mind not having a USB to charge the battery. Like I don't mind if I have to swap the battery out, but Hey, Squire. Yeah, this is a temporary project. I'm doing a video on this nRF7002 chip, and I need to build a board for it. And I'd really like to get the board off by Monday so that it gets back in time. So I decided to commandeer stream time to work on this project. All right. Now, what I haven't mentioned is I was actually working on a second iteration of this, which is actually going to be a later iteration. So I've opened that one up now. One of my plan, and this is, I decided I was originally going to try to do this for the video, and now I've decided not to because it's starting to involve so many moving pieces that I don't want to risk it. But basically, I'm building this same kind of loadout in a feather form factor, which this is going to be fun because this is going to have a single antenna that does 5 gigahertz, and then it will switch between Bluetooth on the nRF53. I'm going to use a 53 instead of 52, or the 2.4 gig on the Wi-Fi chip, and then they've got a bus that they talk to each other so they can determine who gets access to the antenna. So this is going to be a little more fun, but I'm not gonna be able to get that done in time for the video that I'm working on. However, I can at least make use of some of the work we've already done. So I'm going to copy and paste this over. I'm going to paste this like, I don't know, roughly there. All right. So let's move this note off the page because that's just for me to keep track. And I don't think I actually even need the switch on this one, because what's going to happen here is I'm going to use this XIAO module, and I'm going to solder it to the same board as this nRF7002. Now, since the antennas aren't broken out from that module will have its own 2.4 gig antenna for Bluetooth, and then this Wi-Fi chip will have its two antennas for 2.4 and 5 gig Wi-Fi. So they fight over the antenna. Yeah, that's the point of this coexistence bus. Is there's a relatively simple protocol that tells the chips who gets access to the yeah. Okay. So now what I do think I need to do is which load chip. Okay, this is an SOT23. Okay, because this board is actually going to be, I think, pretty easy to solder. Although I think I did use all 0402 parts on this. Yeah, so that's kind of a pain, but 0402 is not terrible. When we get to PCB, I want to see what the layout looks like. I might switch these all to 0603. So we'll see. Hey, Christian. Yes, more pain and suffering. Okay, so so this is actually sort of the project in a nutshell. We'll take this XIAO module, we'll put that on the same board as this nRF7002, and then we'll have we'll basically have Wi-Fi. Now, what I need is to yeah, so I don't need the switch on this one. But what I do need is the antenna. And I'm trying to think, what did I decide on that? So I think if I go to Newark, what I can't remember is, do you still need a diplexer if you're using a dual band antenna? Or can I just go straight into the... This is something I feel like I should know that I don't. Because I wanted to say that this has like two different feeds for 2.4 or 5 gig. Or I think maybe I'm supposed to connect a switch and then the NRF will actually switch depending on... Yeah, now I think about it, I think that's what you're supposed to do. So I do need that switch. Uh-huh. Yeah. That makes sense. Yep, because there's only one feed pad. Okay. No worries. I just realized how dumb that question was. Okay, so let's go back to the KiCad and let's open up this guy. Let's look for an antenna. Antenna chip. Input and passive. Yeah, actually that sounds right. Could actually, yeah, we're just gonna do this. And then in here, we're going to do this. Add in a cellular modem. Well, with solutions from Nordic, that would be relatively easy since they have the N91. That might actually be in 92 and 93 as well, but they have cellular modems, which is what I always thought was funny about Nordic for the longest time. Their solutions were Bluetooth low energy and cellular. There was, it's only in this year that they've introduced the Wi-Fi chip. And I always thought that was kind of funny because it's like, Bluetooth and cellular modems are the opposite ends of the spectrum when it comes to the cost of energy to transmit data. But they've resolved that now. Okay, so I will actually put this on here. And then, wait, this is the... No. I want the diplexer. I don't want to switch. So I need this guy, because the way this is going to work out is we'll just move this over here. How convenient that those are in the right order, because then this comes up to here, and this is going to come up to here because it's low frequency, high frequency. Then we're going to bring this down here. We're going to ground this chip for some reason, and then we're going to have it come out to our antenna like this. And then this gets connected to nothing. Yup. So then for a footprint on this, this might actually work. Let's see. Let us compare. Where did my comparison go? Wi-Fi issue for the post on Discord. You're talking, is that the one I posted today about the two frequencies, or something else? Because that one I did resolve. I did figure out I finally figured out what you're supposed to do. How's it going, Sam? I guess I should say hi before I just immediately answer the question. All right, so this does have a ground pad. Well, that's interesting. I wasn't expecting that. Okay. Well, first up, how big are the pads? These pads are supposed to be 1.3 by 1.7 millimeters. And these pads are, let's reset. And then right here, right by my shoulder, that should be showing, oh wait, no, it's up here. So right over here, I'm using that. So let's see, it's reset to 0, 0. So as I move my mouse cursor, that is 1.37-ish. That sounds good. And then we'll reset up here. And then how big is this? 1 point. So it's actually slightly smaller than what they recommend, which is okay because I can always modify that if we need to. And then for, let's see, do they have a pad to pad distance? That's the keep out. Oh, from the top of the pad to the top of the pad should be 2.75. That's this one. And then from top to bottom should be 4.5. Okay. But I think from here to here is supposed to be 2.7. And that's 2.1. And then from here to here should be 4.5. Okay, so here's what we're going to do. We're just going to remake this in our own image. So what I will do instead is let's go to Footprint Editor, and we're just going to remake it. Yeah, so later in the data sheet, they have a reference schematic, which actually shows which frequency is which. And then they also have a reference board that I'm working off of, which shows which frequency is which. So I did eventually find it. I just thought it's funny that nowhere in the data sheet does it explicitly say this pin is the 2.4 gig and this pin is the 5 gig. And based on that one block diagram, I'm fairly certain that's what's going on. So does Nordic have the CAD models? I don't remember. I don't usually get CAD models from distributors. I feel pretty strongly about this. I think the worst possible place to get technical data is from a distributor, because they make pretty much zero effort to keep their technical documents up to date. So Like if I need a spreadsheet, I will a spreadsheet or a CAD model or a footprint or something. The place I almost always go first is the manufacturer, especially for connectors. Almost every decent connector manufacturer has usable models, and you just search by part number. And so, yeah, I don't. And in terms of downloading like models, I've seen so many horror stories of 602.6.514. I've seen so many like just terrible renderings from. I think it's because they're using automated tools to render stuff from a data sheet. But anyway, I never get stuff from distributor. I can't think of a worse way to spend my time. All right, so let's do this, and then grab this just so that I have that. Yeah, I mean, I think the thing you have to remember is most distributors they don't actually have an engineer on staff. So sometimes they might have an application engineer that might have some experience and they might be able to create stuff. But in general, most distributors right now are just using automated tools to generate their data sheets. And that to me is, I mean, it's fine if you have somebody that is able to review that the data going in is correct in the first place, which most of them don't. Okay, so this is showing us that the feed should be, let me think, how can I do this? Because this is, I need this on the screen right now. So I think what would make more sense is kill this, scrunch this down, cancel this. Let's bring this over here. Oh God, Windows. Make this big. And then how do we hide this thing? We can hide that. For the moment, we can probably hide that. Okay, so that works. So this is showing feed over here. So I'm going to make this mechanical pad, and we're going to make this one 1. Get it? 1. Octopart. Yeah, I mean, it's the same thing. Octopart is they're generally hosting PDFs. Now, one thing, and like I noticed, like DigiKey has started to do a much better job about this, and I think Mouser does a decent job, is a number of distributors have finally listened to their component vendors. And when you click a datasheet link on, say, DigiKey, it will sometimes take you to the vendor's website with the latest version of the datasheet. And so I will use a distributor to look and see if that will work. That's sort of a, but if I click on the datasheet link and it's still digikey.com, then I just close the window. There's, because in that case it's going to be outdated. There's no question to it. All right. All right, so let's create these pad, that pad, that pad. And then, of course, it's not center to center. Why? That would be too easy. So if from top to bottom is 4.5 millimeters, and the pads are 1.75, that leaves 1 millimeter of space between here. So we need to offset these each by 0.5 millimeter. So this should be, so its Y position should be 1.7 plus 0.5 millimeters. Oh, should have been negative. So 1 point, what is that? What is that? 2.25, negative 2.25. This doesn't look right. And this should be 2.25. I did something wrong there. What did I do wrong? The halfway point. So what this should have been is this should have been negative, oh man, something's in my eye. 1.75 divided by 2 plus 0.5. Okay, that's not right either. So that comes out to 1375. This should have been negative 1375. So then from here down to here is 4.4. 4.47 should be 4.5. So that actually sounds right. Neat.
And there was much rejoicing.
Yay. Yay. Okay. So what number did we come up with? Arg. Oh, that's why I messed up. Okay. Because this should have been minus. Yep. And then this one will just be that. Okay, so that gets us correctly on the top and bottom. Now what we need to do is go from left to right. So it's the same thing all over again. So so this is going to be minus 1.35. Oh, I need to figure out the overall. So the overall is, I guess I could just type it all into here. So the minus is going to be the width of the pad divided by 2 minus the over the left right, which is 3.5, minus 2 times the width of the pad, which is 3. And then we're going to divide all of this by 2. Nope, that's nowhere near right. Wonder what I did wrong. Okay, I'm just gonna do it by hand. Okay, so the left half of the page is 1.75, and then we need to scoot that by what am I trying to do? 1.35 divided by 2 is the center point of this, and we need to move that minus, well, you know what, I'll do the positive side and then I can just subtract it for the other one. And then we need to move that over. What the hell did I just do wrong? I need to know, I need to know this gap. That's what I need to measure. So that's 3.5 minus 1.35 minus 1.35. So that's 0.8 millimeters. So then what we need to say is I need 1.35 divided by 2 plus 0.4. So 1075. So this one is going to go to 1075. Oh. All of that to find out it was already in the right place. 0.1075. Right? 1075. 1075. Okay. That's what's dangerous or scary about this pad layout, because I was pretty close. We were pretty close to being correct. Okay. So see, this is saying we should ground one of the pads. That doesn't feel right, though. Hmm. I mean, this clearly says ground pad. But I just don't feel like you should ground an antenna. That doesn't... That doesn't sound right. Okay. All right, and then what's the outline that it wants? It wants a 6 mm outline that starts at 1.9 millimeters after this. Oh, that's hilarious, I think. Right. Okay. And then if I reset this and then come over here, this gets us to 2.8. It wanted 1.9. Why did that? If I said from here to here is 6.6 millimeters, it is. And then 190. Oh, that's the wrong direction. That's why. This should have gone up. Yeah. Yep. So it's going to end at 2. So this should be 2 minus 6.6. There we go. Yeah, I don't want to rotate though because I did it based on the outline of the PCB layout. But this is clearly rotated. So that's what threw me off. Because I'll bet this to here. Nope, 2.3. Oh, because, okay, I know why. If I just move this, because it doesn't give us a clearance from the other side. So I'm just going to, I guess the only way we could know is I could do a line. We can do something like this. Oh, well, that works. Because from there to there is about 1.9, little less. Okay. All right, whatever. And then they want, so then this needs to move over. So I'm using the courtyard to basically establish this this keep out area. Because I figure, why not? Should be this plus 4.7. That's about a millimeter. Okay. All right. Whatever. Okay. Now, I am slightly concerned because this is not, I'm also going to do this because heck yeah. No, where's this at? Wait, what's going on? Try and draw a circle. There we go. Yeah, I just want something a little better than that. So then what is this? Is this a keep out area? Yeah, I think this is. Trying to understand what they drew. So what is this? This is a keep out area, which is probably okay. I get it. I know what they're doing now. They're trying to keep it so that you cannot flood this area, which is a good thing. What is this then? Is this, yeah, this is also the keep out. Except, okay, so because I moved, okay, I see what they did. See, the problem is they kept it out except for the feed right here, which doesn't work for me anymore. Because like this should now be here, and then this one should actually extend to here. But then this one is grounded. So what do we do with this? This is still not right. Still not right. Still not right. Because this needs to come in from here. So we're going to bring this down here. Stop snapping. Don't. Oh, come on. Really? Really? Stop it. No. 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 I guess I could let it snap, and then that way it's the rule area is taken care of. So like this should only be right here. Nope. Can you delete a corner? I don't think you can. Never mind. Like if I add a corner here and I bring this up, this is almost what I want. And then if I bring this down, to about here, and then right here I add a corner because I want, nope, I need one more. Because I want this to come out here, and then we'll add a corner like right there, because this is going to come to here. And we're basically going to do this, which again is just to make it so that the feed comes in through the middle. And then up here, we're going to bring this all the way up. So what's going on here is this should actually be over here now. What is this? What is this? Yeah, okay. Whatever. I was just thinking, this actually should all extend up to here, because that's basically our keep out area. I'm kind of using the courtyard to do both. So insert key to get a thingamajig. And then we'll move this up to here. Okay. So if this works the way I think it's going to work, then we should only be able to draw copper into here. Right. So then if we took this and we rotate this, that should match this over here. We have the mechanical pads, the 1, 2. Okay. So we got that taken care of. Now I want to go and look at our other symbol options. I don't think we're going to have an antenna with a ground pad. I just don't think that we're going to see that. I guess. So let's go take a look at this symbol real quick. Thanks, Tim. That's pin 1. Okay, so that's actually a problem because I drew that backward, but that's okay. I can handle that. Oh no, I did that right. The feed is okay. Wait, or did they call it? Wait, they called it feed, didn't they? Yeah, name is feed. That is pin 1. Okay, that's my feed, and then and instead of no connect, this is going to be ground. See, because you said that, now I'm tempted to leave it or expose the copper somehow so that I can connect ground after the fact. I just don't want to do that in a... oh, I still didn't. Okay. Okay. I forgot. I did this because I wanted to see if KiCad was going to get mad at me. So I'm going to go into my library. We're going to look for a Molex. That's not it. There it is. Okay. Then KiCad. Yeah, it didn't have a MP symbol. So I gotta think about how we're gonna handle that later. I mean, I guess I could just ignore it for now because who cares? The other thing I could do is we'll just do this. I'm going to edit this symbol. And then I'm going to add a pin, and it's going to call, pin name is going to be MP. It will be a no connect, and it will be hidden. And then I'm just going to put it like right here. All right. So then if we update that, now we get no more error. Solve that. Okay. Okay. And then I just want to make sure I should be able to draw a trace. Yep. That's what we want. That way traces can only get in and out right there. That's what we want. Yay. Okay. Oh man, we gotta make another footprint. I totally forgot. Okay, let's do it. It's fun. I like making footprints. So let's fire up this data sheet. And then let's go back into the, oh, I don't know what I just did. Oh, Saturn. Okay. I didn't mean to click on that, but we'll get to using this here pretty soon because this is the Saturn PCB design toolkit, and it has like calculators for everything. I love it. Anyway, that was an accidental click. We're not ready for that yet. So let's go back to our footprint editor. Now this, I doubt there's a, I don't remember seeing any diplexer footprints in here when I was looking earlier, so I'm not going to bother looking now. And instead, we're just going to open up this data sheet and go to this fantastically written diagram. Like, seriously, it's so useless. I think this is the LFD, so that's what we're going to call this. All right, so we'll go to my library, my libraries. I'm going to right click and say new footprint. Footprint name is going to be LFD, Murata LFD. It's a surface mount. All right, so first up we need pads. Really? Come on, guys. Oh, okay. That's not, is this, do they have a layout? That's not going to be helpful. That's the size of the actual things on the diplexer. Oh, so frustrating. So they don't have a recommended pad, like a landing pattern. Whatever. So what we must do then is, life would be a lot easier if I just put two antennas on this. Anyway, so let's go to pad. I'm going to click that because I want to edit this. So the idea is I want to make the right size pad before I start laying them down. And then we'll go from there. Yeah, easier. So the other thing I could do is just say to hell with one or the other and just make it like a 5 gigahertz radio. I just feel like that's kind of silly given that this looks like it should be. I don't think it should be that difficult. Okay, so I believe it's silly, but I believe. So this pad should be, we're going to make this pad. Okay, so this says make it 0.15 millimeters. I'm going to make it twice that so that this is a little more solderable. That's the wrong direction though, right? Because I want it to look just like this one. So yeah, so that's Y. So the Y is 0.2 is going to be 0.2 millimeter. And then X is going to be 0.25 millimeters. Okay. And oh my God, that's tiny. That is so tiny. I'm going to solder this. Now, I think this is the bottom view, right? So if I turn this down, then it should go 1, 2, 3, 4, 5, 6, 7, 8, right? Because if this is the bottom view and I turn it upside down, then 1 is now in this corner, and then 2, 3, 4, 5, 6, 7, 8. That is the data sheet that Murata provides. It's a fancy grain of sand. Yeah, actually I wanted to look. How much are these? I didn't even pay attention. The other thing I guess I could have looked at is, does Snap EDA have one of these? Yeah, 50 cents for whatever this is. In terms of like the pack, I mean, I know what it is. Never mind. That was a silly statement. Oh, they changed their name to Snap Magic, or did they? You know what? I might just use their. Okay, hold on. They've got a footprint. I'm going to use their footprint. And then, so this is where, okay, this is where I often get triggered because people say something that bothers me. They'll make the comment, oh, don't download a footprint. It's always better just to make your own. That way you know it's right. That's the dumbest rationale I've ever heard. What's better to do is to download a footprint and then proofread it, because then you have a much higher chance that it is correct. Creating your own footprint without checking it is no worse than just downloading one. In fact, it's the same likelihood that there's a mistake, because if you don't proofread the footprint you create, then it doesn't matter. I don't know why my password manager is not working. Come on. Okay. So that's what I'm going to practice is I'm going to download this and then we're going to verify it to see if it looks correct. All right, 7-zip extract. And then I'm going to, and then we're going to take this. Now I'm not going to worry about the schematic symbol because I've actually already created that. Also, I worry a lot less about schematic symbols because you might get the pin directions wrong, but then all you're going to get are E or C errors. And so you should be able to self-correct that at some point. So downloading the symbols doesn't bother me at all. Like I feel like creating a symbol is so fast. I would rather just create it because I'm going to end up putting it in the layout that I want anyway. So I realize that's talking out of both sides of my mouth to some extent, but basically when it comes to footprints, I think it's silly to recreate footprints from scratch. So what we'll do is we'll do this. The thing that bothers me is when people make that false statement that I create my own footprints because then I know they're right. No, you don't. Unless you are proofreading them, you do not know that they are correct. And just like with writing or creating any kind of content, proofreading things on your own is always a difficult thing. This is opposite of how I would have done this. Crap. Also, this doesn't have pads 4 and 8. Oh, because there are no connects. But shouldn't it still have the pads, because aren't they there for mechanical stability? Yeah, I'm pretty sure this is backward. Because I think this is the view of the part. And that's part of it. I'm not 100% sure about that, but this is the view of the part. And so this should the pinout on this is wrong. This should be 1. This should be 2. I don't know. You guys tell me if you... yeah, part number is in the link that I provided a minute ago. Although, wait a minute. What's the direction? Yeah, no, this has to be right. YouTube blocked the link. Why would... pin numbering tools. There might actually be a tool that does that, but I don't know. It's so rare to have to redo pin numbers like this. I just don't think that's a huge issue. Okay, so then I should have looked at what are the size of these. This is the pad size is 0.5 millimeter wide. What? Oh yeah, this footprint is way wrong. 0.5 millimeter. See, I see your link. Or wait, do I? Oh man, now I lost chat. Really? Like, really? What the heck? Okay. Let me do it that way. Let me hold, please. I'm going to fire up the old Discord. Fire up. Fire. So, wow, that was weird. Yeah, I don't know what. Oh, wow. Where'd you find this, man? All right, make sure this is closed. All right, let's reopen this. Okay. What do we got? So is this the same part number that I sent a minute ago? I hope this is okay. Yeah. So LFD18G45DCJ247. G45DCJ247. Okay. There we go. This is what we wanted. Man, how'd you find that? I did that earlier, and I got to that terrible Murata page, which I thought was hilarious because they're like, oh, would you like? I'm gonna go do this before I forget. I'm going to edit this library symbol, and then I'm going to edit the datasheet link to be the good one, and then let's do an update symbol and save that. Okay, so now we've got a reasonable LAN pattern. Let's see if we can't... Oh god, this looks like a pain in the ass. Oh god. Shut up. Shut up. Whatever. 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 I don't care. Whatever. So why does this have holes? Right? Why are there through holes on this? Okay. So I'm still not convinced about the numbering yet, but I'm not convinced I did it right either. See, this is showing that the terminals, I think, have a star, right? So star 1, 2, and 3. And then over here, there's these 3 stars. So this is probably the common. And so if that is the common, that means number 1 and number 2, well, that's not going to tell us anything, because they're 1 and 3. But yeah, that's should be how this comes. It goes 1 and so let's see. Low frequency, high frequency. Yeah, okay. So this looks like this should be 1, 2, 3, which means this should be 1, 2, 3, which means this was right. Yep, I agree. The through holes are vias. Oh, they vias for the ground. Because is this supposed to be ground all around? Yeah, because these pins are all ground, aren't they? Okay, that makes sense. That makes more sense. That they're vias. I didn't catch that. And this actually does say the no connects should not be fixed to any pattern. Okay. Good to know. All right, and then let's see now. Our widths should be that's the overall dimensions of the part, so that's not telling me anything. I'm not sure which is this 0.375, which is not, that wouldn't be the right size. Then what would be 1.25? Okay, 0.125 looks like it's from the center line to the side of the pad. So this whole pad should then be 0.25 in the X direction, except this is turned, so the Y should be 0.25. So then that looks like that's correct. And then same thing on, let's see, can we do the same? Not, so this starts 0.2 up, 0.7, 0.5. Okay, so this is, so this does look like this is it looks like this footprint does match that landing pattern. So then if we go from center to the end, this should be, so from center to here should be about 0.625, and this is showing roughly 0.635 because of my grid, so that looks right. Okay, and then let's do one more measurement and I'll feel good about this. So that goes from there to there. So from here to here is 0.2, and then out here should be 0.7. Okay, that looks pretty good. Okay, so that actually, so this is actually, I would say this is a pretty decent, this would be a pretty decent footprint to work from. The only other thought I have is, should we define the keep out areas? Because that looks like a pain in the butt. However, I'm not sure I understand what they're saying here. So this hatched pattern is solder resist. And then this white section, this non section, is no pattern, solder resist. Is this saying that there should be, this is the keep out? Maybe that's what this means, is they don't want any copper through here. That must mean what that must be what they're trying to say, because then that means that this pad would effectively be isolated, and then this pad would effectively be isolated, and then your 50 ohm trace can come in here. Yeah, I think that's what they're trying to say. So let's just take a wild stab at this real quick. Man, this would be easier if I could just rotate everything. Oh wait, I just realized what I could do. Why don't I just grab this and we'll go into pick. Right, because pin 6 is ground. 1 and 3, or 6 is common, so 1 and 3 are my ports. All right, and then let's go boilers. All right. That's basically what I'm trying to do. So let's bring this over here. Oh, RF is fun. Not. Let's do zones. So what they're saying is they want a thing. I don't have any measurements at the moment. I'll come back to that. Because this somehow comes up here, and then it kind of comes up here, and it kind of comes up here. I'll just get the vertices and then figure this out, right? Because then this is like, I feel like this is what they're trying to draw, something along those lines. So I feel like what they're concerned about is, and I could probably actually simplify this. Maybe this would be a better way to do it, is if I said, okay, let's just do one here that keeps out, I want to basically keep out copper floods, which I guess I could just draw around this, but I think what they're trying to have you do is make sure that you don't, that you have a little bit of margin for the ground. Did that wrong. That seems like the thing that I would worry the most about is, so we come out here like this. I actually think that's about all it needs. And it's basically to just prevent flooding this area inside with ground. Well, what I'm saying is their directions say, and this is why it's I get yeah, I'm making this more complicated, but this is saying where there is no pattern, there should be no so where it's blank, there should be no copper pattern and there should be solder resist. And so what this drawing is showing is that this sliver right here should not have any copper, and this sliver over here should not have any copper. And so I think I get what they're trying to do there, is because then I'm going to have my trace come in here, from here and here, and then into here, and then ground is going to be here. But what we don't want is, we don't want like ground, we don't want this pad itself to be surrounded by ground. I think that's what they're trying to get at. Like, I think that's the key takeaway. So I think we're going to go with this for the moment, because I think that's all that's really trying to do. Yeah. Well, I think what they're trying to say is, you have to, just like in a strip line, right? You have to have a gap between the signal, the ground, and the signal. And so that's what they're trying to illustrate here, is this is what you want this to be, like that. So anyway, it probably, yeah, it doesn't matter, because we'll end up getting this right anyway. What this does allow for is, this will prevent us from accidentally putting copper in here. Okay, let's go with this. I'm satisfied at the moment. Let's go footprint. And then let's see, we just downloaded this, right? Yeah, so I'm going to keep it as a download it. Yeah. Yeah. It's, I'm only putting the rules in there for now. I'm not going to worry about it until I'm serious about layout. Because yeah, I was going to try to copy what they were showing, but it's not worth the effort right now, because I'm not gonna follow it anyway. All right, let's see now. Update pad 4 and 8 not found. What pads 4 and 8? Oh wait, you know what? I know why. I'm going to, because I had these in here, I'm just going to delete them. There. And then we'll update, symbol, update, close, F8, update, update. Okay. Yeah, it's starting to look good. Yeah, okay. This isn't going to be the way I planned to do this, like usual. Why doesn't this have a courtyard? Really? This doesn't have a courtyard? All right, whatever. I'm going to add one real quick. Just something basic. Yeah. Okay. And then the other thing we're going to do is, while I'm thinking about it, I'm pretty sure. Let's go check real up. Nope, not this one. Where's it at? This one. This one. I'm pretty sure this has a Bluetooth antenna on it. Yep, it does. Right on the edge. So we need to, Bluetooth it. So I'm going to, before I forget, we're just going to put a keep out area right here. Oh, you know what? I'm going to add the internal layers now. This is going to be a 4-layer board. Even though it's going to be a relatively... Wait, which one am I doing? Yeah, we're going to do this as a 4-layer board. Because I need the impedance. I need a 50 ohm impedance, and I don't want to try to figure that out in a 2-layer. Unlike the RP2040 in USB, yeah, we're just going to make the middles copper or ground. Or maybe I'll do power. Oh, maybe I'll do ground power signal. I'm not sure yet. I just know I want it to be 4-layer. But I could also ultimately, no, I don't want to do it that way. Keep out copper fills. Okay, so then I'm just going to do something like this. Oh, why does it draw 90 degrees now? I hate that. I hates it. There. A Nixie watch. I mean, I think they're cool. I don't have any desire to make one, but I can understand why people do. I think it's... I would rather have, like, I don't know, maybe a Nixie pocket watch would be more useful, I think, or something like that. But, like, I don't know, because I think Wozniak for a long time had a Nixie watch. In fact, I think he even talked about how impractical it was because you had to press a button to make it work, and it was only 2 digits, so it would show the minutes or the hours and then the minutes. Yeah, so anyway. All right, so let's go ahead and move all this over here. I'm going to move this to roughly... Oh, well, that's weird. I'll have to look at that footprint later. So let's see. Oh, I haven't defined the mesos yet. That's cool. But this is basically going to connect via serial to here. And then I think this will have its own power supply. And then this will be, let's see. That's probably going to be our RF. And then we'll have this antenna over here like this. So probably do something like this. And then we'll end up with a board sort of like this, I think. You know, something along these lines. If we did that, how big is this going to be? Let's call it 40 by 25 millimeters, which is very conservative. Yeah, so 40 bucks shipped. Yeah. Which sucks because I'd really like to get 2 of these boards done at the same time so I can amortize the shipping cost, but flip the XIAO to the backside and make it even smaller. So the challenge is I'm purposely using, and this is sort of a this is almost like it's a so ultimately this is for a video for Nordic to show off the nRF72. And what I initially told them I would do is I would use the nRF52 XIAO and create a board where I connect the two together. The reason I'm bringing that up is because we could pick a XIAO that doesn't have an antenna, but this does mean there is an antenna and a USB port on this board. And so, I'm not sure where we could, I'm not comfortable putting this RF part on the back side of this board because of this stupid Bluetooth thing. I just feel like that's asking for interference. That might actually be an interesting variant to make and see how it comes out. That could be kind of fun and interesting. But I have a feeling that's not going to work out the way I want it to. Yeah, what I meant on the PCB, on the combining boards thing, is I don't have both boards done. So I would just like to, if I had both, I would like to submit the order and have them ship both boards at the same time, so I'm not paying twice as much for shipping. But where I'm kind of going with this is, if we put this like, then doesn't the Wi-Fi antenna have to be on the backside as well? Right? But like, even if I did something like this, what worries me is, well, I guess we'll have multiple layers. Yeah, is there's going to be 50 ohm traces running underneath each other at some point. Like, there's not a way to get around that. But I guess the antenna is actually more over here, so we could just kind of shove this whole thing over this way. Do they have a mechanical drawing that we could use so that we could better define where that Bluetooth antenna is at? Because I would really, that's what I'm mostly worried about at the moment, is that Bluetooth antenna. So do they have a drawing? Oh, there is a battery charging circuit. Crap. Well, then how do I get... I'm liking this idea less and less the more I think about this. So I'm going to try to import this DXF and let's see if we can, if it gives us a better clue to, let's see, let's go for user 9. Okay, that's fantastic. Yep, that's cool. That's totally not scaled correctly. Wow, okay. But this would give us where the antenna's at, so that could be useful. Yeah, it's still way too big. So what is this distance right now? So about 6.5, right? What's 645? That doesn't sound right. Because that should be 5.0, or that 2.54 divided by 6.5. I wonder. I've had this problem with CVGs before. I've never had this with a DXF. Nope. I thought I was going to be 30%. Do they have a ruler that I can use? Oh man, I think KiCad just crashed. I would try the automated footprint generator first, just because it might save you time. At the very least, it might give you an idea of, like, when you go to draw it, if you have to draw it manually, it might at least get you through the steps of all the things you need to think about before you start laying it out. Okay. This is so annoying. All right, so let's just get Illustrator open and see if this works. Yeah, because I guess what I'm thinking about is if we could line this up correctly so that the Bluetooth antenna and the Wi-Fi antenna are offset, it's sort of like it'd be the same thing as if they were on the same side of the board together, right? So the other thought I was having is because I was planning to solder the castellated pads onto the board. If I really had to, what we could do is we could use headers, plug it into the headers, and then put all of these parts on the top side. But that's stupid. That's the same thing. I'd rather just put it on the back side of the board and make the whole thing a little bit thinner. Come on. Open. Let's see. It is an unknown format. Well, that's a lie. I am fairly confident you know what a DXF is. Nice. Who else knows what an Inkscape is? DXF is. Yeah, I saw the last box had something. I just it's having such a hard time with opening the file. I was hoping that maybe if we load it into a vector program, we could at least manipulate the file a little bit better. Because KiCad is locking up trying to handle it. I think there's too many elements in it. And all I really care at the moment is I just want to measure where it's supposed to be. So if I can always scale that out of something else. Wow, now Inkscape looks like it's having trouble too. Well, shucks. Yeah, except they don't provide it as an Eagle board file. They only provide it as a library, and 7 doesn't import library files directly yet. I think in 8, and that I did briefly think about, I could load it into 8 nightly, or the 7 nightly, the nightly build, and try it that way. Oh, I see what they did. So they exported their Gerbers as whatever. I don't have the energy for this. I'm too old for this stuff. Okay, so all I cared was here's the antenna. So it's basically on the left half of the board. Man, this looks like a nightmare to handle as well. I thought the footprint generator did SOICs. I mean, it has all the SOICs, right? So, okay. This is ridiculous. I have way too powerful of a computer for this to be a pain in the butt. Just saying. If I can't manipulate this file, I don't understand how anyone else can. All right, maybe it is working now. So what did this come out at? So let's first go from roughly here to here and see if our scale, oh, come on. I don't know how to use Inkscape, so I'm kind of doing this the only way I know how. So this has a width of 2.8. Yeah, so that actually looks like that's about 2.54. So I think this is actually scaled right. KiCad just must be munging it up pretty bad. Because that's about 2. Okay. Yeah, so basically all of that, all I wanted to know is it runs about 8 point, let's call it 8 point, oh no, that's X with height. If I said 9.5 millimeters from the edge, and then let's call that 2.25 and 9.25. Better go with 9.5. So 9.5. Let's go, and 3. All right. So basically all of this, because all I wanted to be able to do was say, okay, so really what we should do is create a keep out that goes to about call it there. So then I can grab, undo all of this, only grab the rule, move this over to here. All right, and then we'll grab the graphic and not the rule, so I can delete that. And then let's just draw something from, I guess rough, I don't know what line, oh, okay, that was my edge cut. And do this up to about 3 millimeter. Okay. So then the rule is going to be up here. And then I'm going to bring this back in because clearly that's... Oh, come on. Really? 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 So the radio is roughly here somewhere. I guess I could actually figure this out now, can't I? Now that I've got this box thing. I wonder what that is. What is that little thing? Yeah. Okay. So we'll just do the keep out. I'm just gonna do the keep out this way. I'm just gonna bring the keep out to roughly there, and that should be good. So okay. Sorry. So all of that now because then what we can say is, well, if we put the antenna, can we put the antenna? Not really. It's not really how I would like to do it. Because then this is going to radiate, because I think they're trying to say this is the radiation pattern. And so we really don't want it under those pins. Vector BIOS. Yeah. I'm just saying. I mean, I know KiCad's not the most optimized application, but still. I don't know. I'm not sure how I feel about this yet. Because the only other alternative is we do something like this and then just have this like stick out a little bit. I guess we could like put like some funny text or something on here. But if we did this, then yeah, we can really we could easily get this to fit on the back side of this. Maybe we need to try. I think this is for power anyway. So this should go up here somewhere. And then this can come down here. I'll just do this real quick. Align left, align distribute. And then actually what I should do is just do this. I just want these to all be scrunched up together. I don't really care. And then I can do align to left. Align distribute. So much better. There. Then we can kind of move this to be about the center there. And then these can come in here. These will come up here somewhere. These can come out over here somewhere. And then we just dramatically reduce the footprint of this board. Like cut it in half. Okay, I think we're gonna head in that direction for now. We'll see how it turns out. There's a couple of, let's see, did I want to change something in here? So I wanted to change I don't remember what the pins are. Shoot, I gotta look that up because we're not gonna use QSPI anymore. And then I think I can not route the maybe I'll run those out to test points because I don't think I need those anymore. Because we're not talking to the other board anymore. Yeah. Okay. All right. That's going to get us to where we need to go for now. I'll keep working on this tomorrow. I work on some other stuff now. So I think that's going to work out. I don't know. I'm not super sold on this yet, but in fact, I think one of the things I'm going to end up doing is I'm going to just from a logistics point of view, I'm actually going to flip this to the other side. I'm going to flip the XIAO to the other side so that I'm working on the front side for the circuit where I'm actually routing stuff, just out of just to keep my mind straight. But yeah, I don't know, this might work out. We'll see. So, all right, we'll see how this works. Cool. So next Thursday we'll probably be back in the Apple II schematic next week, because I plan to have this done by Wednesday anyway, because I really, by Wednesday is kind of my cutoff. I gotta get this in process by about that point anyway. So yeah, so Thursday we'll probably be working on the Apple II schematic again. There is another PCB project that I want to do, but I don't think I'm going to do that. In fact, now I think about it, I'm probably just going to stop that for now because this is going to be harder than I thought. So, yeah, we'll see how this works out. So the other thing I'm thinking about is if I want to add the light sensor to this board. I don't think I do. I think I'd rather have Yeah. Okay. All right. Well, thanks for hanging out, guys. Appreciate it. Thank you for the help as well, because definitely helped me go a little bit faster. So same time next week, 2 hours. So whatever time it is for you right now, subtract 2 hours. That's when I start. And so next Thursday we'll be there. And then of course you can always catch me on Discord. I don't know if I'm going to try this, but there is a new Workbench Wednesdays video. I went and visited the Eaton Industrial Controls truck, which was kind of fun. It's kind of cool, something a little bit different. So you might want to go check that out, or you should go check that out is what I meant to say. That came out on yesterday. Came out yesterday. So cool. All right, guys. Catch you later. Bye. Thanks again.